Welcome back. In this video I will talk about endogeneity. First I briefly explain what it is, then we find ways to detect endogeneity, and finally we talk about ways to address it. What is endogeneity? So when we look at a standard regression model, like in this case, where we try to explain on the left hand side the return on equity, so a measure of firm profitability using firm size and financial leverage, in this equation it is quite plausible that one or both of the independent variables they might be determined by other unknown factors. And this might cause a relationship between the independent variables and the error term. If that occurs, so if there is a correlation, say, between financial leverage and the error term, then you violate OLS assumptions and endogeneity is present. Now this will bias your regression model. In order to detect endogeneity, what you could do is you could try to explain one of these independent variables with a set of other variables and see whether this model, and this would be here model 2, gives significant explanatory value. So the idea is to ask yourself, is it really the case that all the so-called independent variables are truly independent? Now, in order to test endogeneity, what we do is we run this model here, and we would estimate from the equation 2 the residual. The residual is the unexplained component of leverage. And we use that back in equation 1, and then we check whether this residual has an impact on our dependent variable. If this is the case, we would argue that endogeneity is present. Now if you just think about this for a second, just to think about the logic, let's assume that leverage is really pretty much independent. So put differently, the right hand side doesn't really explain anything. In this case, leverage and the residual would be identical. If they are really identical and I put both into equation 1, well, one of them will simply drop, because there would be collinear, and Stata would simply remove one of them. So there would not be any endogeneity. So endogeneity would be an issue if there is a significant proportion of the independent variable, so-called independent variable leverage, explained by a set of other variables. Let's try this in Stata. So I opened Stata. I will work with the same farm yields data which we have used before. I now just save the do file. I just call this attempt because we anyway just play around a little bit. I change the directory to my directory where I keep the data set. Again, as you know, all the data, all the code is available on GitHub, and you see the link in the description down below. Again, if you have any comments, any suggestions, please leave a comment below. This is much appreciated. I will try to get back to you as soon as possible. Okay, let's just run this do file and open the data, which I have done. So now we opened the data, and again we have our different farming products like wheat, barley, the oil seed and milk for an extended period of time. So these are time series data. As discussed previously, we want to move into changes of these yields using the time series operator D. In order to do the time series operator, I have to tell Stata first that I have a time dimension. So I use tset and I specify year, because year is used here to indicate the time dimension. And then it might be useful to simply have a look at my data using line charts, to combine different line charts into one plot. I use the two-way command, and then I specify different line charts. The first one would be my target, potentially the change, so D dot in oil seed, and this again will go over time, so year. And now I'm a bit lazy, I just copy paste that a few times and modify it accordingly. So here we have then, I believe, barley, and we might maybe change the color here to make it easier. I just use red, that's strong enough. I do a line break just to make it look a little bit more tidy. And I then have, I believe, wheat. And again, I could change the color. I might do maybe blue. And finally, we have milk. And I change the color to maybe green. Let's just do that. So this is just to visualize the data. Okay, I just save it, I run it one more time, and now I have this time series where I look at the changes in yields, and you see they seem to co-move to some extent. Yeah, and of course, maybe this is something we can exploit to understand changes in oil seeds, looking at the other variables. Good. So the next thing we do is we just use now very straightforward regression models. Again, I'm not an expert on agriculture, so we just now run these models and see what happens. And I start with my dependent variable. I want to understand the change in oil seed, and I use for that barley. And then I will run several specifications. We have done this before because it might be maybe useful to add some more variables to it. So I will just run a few specifications. One where I also include wheat, for instance, and the final one that also includes milk yields. Again, it might be nice to only show a few parts of the results. So I do here an estimates store, and I store it under A. So I do something similar here, and we just store it under B, and we do estimate store C. I don't want to see all the outputs, so I do a quiet. Just before running it, I do the wavy brackets to specify it as a block. I don't need indentation, but I quite like to use it to make it clear where the block starts and stops. Now this is running my regression models, 3 of them, different specifications, and now I want to have one table combining all of them. So I do here estimates table, and then A, B, C, and then I specify what I want to have. I want to have star for significance level, and B would be my coefficients, and I want to have a fixed format with 3 decimal places, and I want to have a few statistics here. It would be nice to have number of observations and my adjusted R squared, and that is it. We have done all of it. So let me just now run this. So it provides my figure, and here we have our outcome. So we see that barley has a significant impact, but that is useful, and we get an adjusted R squared of around 12.7%. It's not amazing, but I think it's acceptable. It's not a bad, at least some predictive power. And the additional specifications, they don't really do anything. You see the R squared, the adjusted R squared doesn't improve. So specification A would be our model 1, so to speak. Yeah, so that would be here our equation 1, which we will use later when we talk about endogeneity testing. Yeah, so this would be here equation 1. Okay, now we are a little bit suspicious, and let's test for endogeneity, just to make sure. So let's run our test here, just to be a bit more confident. Now in this case, what I could do is I could try to explain now barley. So this is our equation 2 on the slide. So I explain barley using the other 2 available independent variables. Yeah, so this is basically running what you call sometimes an auxiliary regression, so a regression which is needed to actually derive a statistic. So in our case, what we want in the end here is we want to predict now our residual. So we use the option res for residual. And so let me just run this first and see what happens. And as you can see, there is some predictive power coming from a change in wheat yields, quite a substantial R squared. And now we saved here our residuals, and we now use these residuals in equation 1. So we go back to equation 1. So back to equation 1, and we use in here our residuals, and we in particular now look for the coefficient that comes with the residual which we include in equation 1. If this coefficient is significantly different from 0, we would actually confirm endogeneity. Let me just run this. And in this particular case, we still see barley has a significant impact. You see it in the p-value. The p-value is below 0.05. And interestingly, the residual actually doesn't have any significant impact. So here, endogeneity would not be the concern. So that would conclude our test. Now, what if there is a problem? So what do you do? How can you fix it? Well, the standard solution, in particular in the econometric literature, is to look for so-called instruments. So you look for an instrument which has a high correlation with the suspicious variable that causes the problem, but is uncorrelated with the error term. Now, in principle, this is a nice solution. The big problem in practice is how to find these instruments. Yeah, so I have done some work on these issues in the context of measuring climate risk. Yeah, so there are sometimes ways to construct instruments, but it's not always straightforward. What else can you do? Well, sometimes it might make sense to go into structural equation modeling, where you can model more complex relationships, or you might add a time dimension to your problem. We actually have one here, so we could do different types of models under the heading of, for instance, vector autoregressions, which I won't cover in this course, but I will do another course on applied time series modeling, where this will be featured. So there are alternatives that you could try to exploit that might give you a better understanding of these relationships, in particular if variables are interrelated. Yeah, so where there is no clear independent or dependent variable. Good, that's all for today. I see you in the next one.